All right, so in today's session, we're going to take a look at Module 1, Section 3. We're going to talk about point slope form, parallel and perpendicular lines, and we are also going to write some equations in the latter part of this session today. All right, but before we talk about the point slope form, let's review our slope, because the slope is going to be a critical concept throughout this section and much of Module 1. So as far as the slope is concerned, the last time we met, we saw that the mathematical symbol for slope is m. We were able to manually calculate a slope by using an imaginary triangle to calculate the rise over the run. We also looked at the 4 classifications of slopes: positive slope, negative slope, zero slope, and an unidentified slope. We also had taken a look at how to find the slope through 2 points: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We also had taken a look at slope-intercept form. Right, in slope-intercept form, y is equal to mx plus b, where m is your slope, b is your y-intercept. And we found that in order to write out the slope-intercept form for any graph, we only need 2 items: the slope and the y-intercept. Right, so we calculated the slope manually and by the formula, and we were able to pull out the y-intercept. Today we're going to talk about, and this is when we were given a graph. If you're given, not necessarily a graph, but if you're given some information about a graph, such as its slope, a point that it passes through, a line that it's parallel to or perpendicular to, you can actually write the equation using something called the point slope form. So anytime you're asked to write an equation, you want to use this formula, and it's called the point slope form. And it's y minus y sub 1 is equal to m times the quantity x minus x sub 1. All right. And I am running out of room. Okay, so in this formula, y minus y sub 1 is equal to m times the quantity x minus x sub 1. M is the slope. Right? And x sub 1 comma y sub 1 is a point on the line. The reason this is called a point slope form is because in order to use it, you must know a point on the line and you must know its slope. If you're given a point on the line and if you're given a slope, you can write out this equation by using the point slope form. Now, you're never going to know x and y, right? But you should always know m, which is your slope, right? And we have several ways to calculate the slope. And this x sub 1, y sub 1, that would be the point on your line. All right, so let's take a look at some examples. So here we're asked to write the equation. Okay, now we're assuming where it says write the equation, we're writing all of the equations in slope-intercept form. So here's an example. Write the equation of a line that passes through (3, -3) and has a slope of 5. All right, so write the equation of a line that passes through 3, -3 and has a slope of 5. So I'm just going to jot down some information. I'm going to jot down the slope. So m is equal to 5 and it passes through 3, -3. All right, so I'm just kind of pulling out the two things that we need to write this equation. So we were asked to write an equation. So automatically we're going to consult the point slope form. So that point slope form is y minus y sub 1. That's equal to m times the quantity x minus x sub 1. So in this point slope form, remember that m is the slope, right? So m is going to be 5. And the point it passes through are our x1 and y1. So I'm just going to substitute. So remember now, we never know y or x. So I'm going to bring down y. I'm going to bring down a minus. Y sub 1, which is a -3. So I want to make sure that I substitute in a -3. That's equal to m, right? And m is 5. Times the quantity x. And remember, we never know x, right? X and y are our variables. Minus, because that's a part of our formula. And x sub 1 is 3. All right, so now I am going to change my signs. On the left-hand side, that double negative is a positive. So on the left-hand side, we have y plus 3. On the right-hand side, I'm going to remove the parentheses. So I'm going to use distributive property, right, and multiply everything within the parentheses by 5. So 5 times x is 5x. 5 times -3 is -15. And we want to put our final answer in slope-intercept form. So that basically means we want to solve it for y. So in order to solve for y, I'm going to simply subtract 3 from both sides. So y is equal to 5x minus 18. Right, so the equation y is equal to 5x minus 18. It has a slope of 5 and it passes through the point 3, -3. All right, so we have our first example. All right, so let's look at another example. So here we're asked to write the equation. write the equation that passes through and I am making this up, so I need to be kind of careful. So this is passes through 2, -2, and let's say -3, 1. Okay. So notice our setup is a little bit different. In the last problem, we were given the slope, we were given a point on the line. So we just kind of put everything in a point slope form and we were able to use it. Okay. Here I'm given 2 points and no slope. So just remember, whenever you're asked to write the equation, you're going to use the point slope form. Okay, I'm just kind of going back to my notes here. You're going to use this point slope form. And in order to use the point slope form, you must know 2 things. You must know the slope, which we don't have, and you have to know a point on a line. And we're given 2 points on the line. So the first thing we're going to do is find the slope. So the first thing we're going to do is find the slope. So how do we find the slope? Well, remember there was a formula to find the slope through 2 points, right? It was y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So I have my points. So this is my first point. I'm going to label this x sub 1. I'm going to label the second coordinate y sub 1. And in that second ordered pair, set x2 and y sub 2. So the formula for the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we will substitute. So y sub 2 is 1 minus, because that's a part of our formula, y sub 1, which is a -2. So I have to be careful and make sure I substitute in a -2. Divided by x sub 2, which is -3. Minus, because that's a part of our formula, x sub 1, which is 2. All right, so in the numerator, that double negative comes a positive, so 1 plus 2 is 3. In the denominator, -3 minus 2 is -5. A positive divided by a negative makes that entire number a negative number. So our slope is 3/5, -3/5. All right. So that was the first part. The second part is we're going to write the equation using the point slope form. Right? So remember, in order to use a point slope form, we need to know the slope, which we just calculated is -3/5, and we need a point on the line. Now, it doesn't matter which point you take. You can use that newfound slope, and the first point, you could use the newfound slope and the second point. Doesn't matter which point you choose, it's the same line, so you should calculate the exact same slope. But I'm going to use the x1, y1. All right, so here I'm just going to write out all of the ingredients I'm going to use over here. So m is equal to -3/5, and it passes through 2, -2, and that's my x1, y1. All right, so now I'm just going to rewrite the point slope form. All right, so remember, we never know y or x, okay, but we should know everything else, right? M, which is the slope, and x1, y1, which is the point on the line. So now we're going to substitute. So I'm going to bring down y minus. Y sub 1 is a -2. So be careful and substitute in both the negative and the 2. Right, I encapsulated that in a set of parentheses. That's equal to m. So our slope we calculated is -3/5 times x minus 2. All right, so I'm going to change my sign. That double negative is a positive, so that's y plus 2. And I am going to distribute -3/5. So -3/5 times a positive x is -3/5 x. -3/5 times a -2. A negative times a negative is a positive. When you multiply a whole number times a fraction, you can multiply your whole number by your numerator only and keep your denominator. Right? So a negative times a negative is a positive. I can multiply 2 times 3 to get 6/5. Right? So now I need to solve it for y. So I am going to subtract 2, right, from both sides. So I'm actually going to write this step so you can sort of see what I'm doing. So y plus 2, I'm going to subtract 2 from the left-hand side. I'm going to bring down -3/5 x plus 6/5. And I also have to subtract 2 from the right-hand side, right? So this is what I'm going to do. Since I have a fraction 6/5 that is on the right-hand side, I'm going to rewrite 2 with a denominator of 5, if that makes any sense. So on the right-hand side, I have a -10 divided by 5, right? Which in fact is a -2. I'm doing the same thing to both sides. I'm subtracting 2 from this side, and I'm also subtracting 2 from this side. Right, this 2 simply has a denominator of 5, that's just going to allow us to combine the fraction. Right? So simplifying on the left-hand side, the 2's cancel, we have y. On the right-hand side, I'm going to bring down negative 3/5 x minus 4/5. Right? Because when you combine fractions, add or subtract fractions, you keep your common denominator and you combine your numerator. 6 minus 10 is negative 4. All right, so sorry for that confusing answer. If that was confusing, I made it up. So, all right, so any questions about this example? All right, so this example, we actually had to find the slope. Okay, so here we want to write the equation of the line that passes through negative 3, 3 and negative 3, negative 5. All right, so same setup. We're given 2 points, right? We're asked to write an equation. So we're going to keep in mind the point slope form, which requires the knowledge of both the slope and a point on the line. All right, so just like in the last problem, we're going to have to find the slope. Okay. And I didn't actually do this on the last problem. But if you look at your ordered pair points, and we talked about some special lines in our last class. I'm actually see if I can pull that up. We talked about horizontal and vertical lines. And I think I mentioned that if your x coordinates are exactly the same, that alludes to a certain type of special line. And then vice versa, if your y coordinates are the same, then that alludes to a special line. Correct. So here's what I am alluding to. I want to go back to the shared screen, and hopefully I can find it. I believe this is it. Or was it before that? I think it was before that. Okay, I thought it was up somewhere close. I'm not going to waste too much time trying to find this. Okay, but we did graph lines Okay, I'm not going to try to hunt that down. All right, sorry about that. I thought I could just pull that up real quick. But nonetheless, notice that it doesn't matter what y is equal to, but x has to equal -3. So the equation here, just by visually noticing that your x coordinates are exactly the same, right? This should be the equation without any work, just by knowing certain facts about your ordered pairs. Right? But let's just say you didn't quite catch that both the x coordinates are the same. We can still work it out. Okay, we'll just see what happens. So I'm gonna do this kind of quick. So this is x1, y1, x2, y sub 2. So first thing we're gonna have to do is find the slope. All right, so if I take y sub 2 minus y sub 1 over x sub 2 minus x sub 3, excuse me, over x sub 2 minus x sub 1. So we have -8 over 0, which is undefined. So remember that if you're dealing with a vertical line, right, it has an undefined slope, right? So the slope is undefined. Right, so now if you were to use point slope form, y minus y sub 1 is equal to m times x minus x sub 1, right? Notice how everything breaks down because the slope is undefined and there's nothing to substitute in for the slope. All right, so it actually breaks down when you use this slope point slope form, and if you find the slope, you may think that you are running into some troubles because you get something that looks kind of weird. You don't get an actual number value. So here's what's going on. Both of your x coordinates are exactly the same, so it's an x equal to, it's a vertical line. So now let's look at the opposite. Let's say we have find the equation through -1, 3 and 5, 3. So here again, if you look at your points, the y coordinates are exactly the same. So it doesn't matter what x is equal to, y must equal 3. Therefore, the equation should be y equal to 3. So I really want to waste too much time working this out, but I do want you to visually look at your ordered pair points, right? If the x coordinates are the same, it's an x equal to vertical line. I mean, you can even plot these points, for example, right? If I were to plot this point or these 2 points, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I can plot this point -1, 3, so I'm at the origin. X is -1, so I'll move one place to the left. I would go up 3, 1, 2, 3. I'm going to plot this point 5, comma 3. So I'm at the origin. X is 5. I'm going to move 5 places to the right. 1, 2, 3, 4, 5. I'm going to go up 3. And we have that horizontal line. So just like any other example, if you were to graph that, it would graph a vertical line. Okay. So now we're going to talk about parallel and perpendicular lines. Right. So the mathematical symbol for parallel are two like parallel bars, and not the parentheses. Normally you see parallel, you just see the, two parallel bars. And the mathematical symbol for perpendicular is an upside down T. Now, perpendicular lines form a special type of intersection. Perpendicular lines intersect to form perfect 90-degree right angles. So you can have two lines across, that make, I guess, like an X, but perpendicular lines will intersect and make a perfect cross. All right, 90 degrees. All right, so parallel lines have the same slope, right? So two lines are parallel if their slopes are exactly the same, right? So remember that parallel lines never intersect, they never touch. Perpendicular lines perpendicular lines I want to see how I can actually write this. There's a formula for perpendicular lines. It says that m sub 1 times m sub 2 is equal to -1. So I like to write this out in the words. For perpendicular lines, the product of the slopes, and product means to multiply. The product of the slopes is -1. So that means when you multiply the slope of one line by the slope of another line, if that product gives you a -1, then those two lines are perpendicular. They form that special 90-degree intersection. Or one slope is the negative reciprocal, and we're going to talk about that is, or about what this is. Or if one slope is the negative reciprocal of the other. All right, so two definitions. Parallel lines, they never intersect and they have the exact same slope. Perpendicular lines intersect, they form a special 90-degree intersection, and the products of their slopes is a -1. So before we actually talk about, we'll talk further about parallel and perpendicular lines, let's talk, I guess, again about slope. But this time we're going to talk about how to find the slope of a function. Right? We found the slopes of graphs, right? The rise and the run, y sub 2 minus y sub 1, all that. Here we're trying to find the slope of functions. To find the slope of a function, the function must be in slope intercept form. And I should put a little star by that. So if you're given a function, and if you're asked to find the slope, you must take your equation and basically solve it for y. All right. So we're just going to look at a few examples. In these examples, we're asked to find the slope. So y is equal to negative 4x plus 5. Right? So if this is my equation, right, y is equal to 4x, negative 4x plus 5, what is the slope? Well, this is in slope intercept form, right? To solve for y, the slope would simply be the number part of your x variable. So here, the slope should be negative 4. All right, so the slope is negative 4. So another example, right? Find the slope. 2x plus 3y is equal to 9. Well, if I'm asked to find the slope here, this is not in slope intercept form. This is in what you call standard form. I'll talk more about standard form in just a second. But in order to find the slope, our equation must be in slope intercept form, which means that we must solve it for y. So I'm going to solve this equation for y. Right, so the first thing I'm going to do is just locate which side of the equation my y variable lives on. So it's on the left-hand side. Also on the left-hand side, I have 2x. I'm actually solving it for y. So since my 3 and y are attached, that's one term. I'm going to take the 2x and I'm just going to move it to the other side. I'm going to transpose it or subtract 2x from both sides. So now I'm going to have 3y is equal to negative 2x plus 9. Right, I simply subtracted or transposed 2x. Now I want to solve for y, not for 3y. So the opposite of multiplying y by 3 is to divide by 3. So I'm going to divide every term by 3. I'm going to put this extra step in. All right, so everything gets divided by 3. So on the left-hand side, the 3's will cancel. I'm left with y. On the right-hand side, I now have negative 2/3 x. Nine divided by 3 is 3, so that's plus 3. And now I'm in the right form, so I can determine what my slope is. So my slope here is negative 2/3. And remember, the slope is the number part only. Okay, never include the x variable with your slope, right? Slope is only that quantity, that numerical portion. All right. Okay, so now let's put this all together with a couple of problems. Okay, so here we are asked to find the equation of the line parallel to y equal to 3x plus 4 and passes through -4 comma -14. Okay, so here we ask to find the equation of a line that's parallel to y is equal to 3x plus 4 and passes through -4 comma -14. All right. So here we ask to find an equation again. So we're going to consult the point slope form, which means that we need to know the slope and a point on the line. The slope that we're going to choose should be the slope of a line that's parallel to this line, right? Y is equal to 3x plus 4. So first I have to determine the slope of this line, right? So I'm given the equation y is equal to 3x plus 4. It's in slope-intercept form. So my slope is 3. Recall from parallel lines, two lines are parallel if their slopes are the same. So the slope of this line is 3. Therefore, the slope of my line should be 3. Right? So I'm going to use a slope of 3, and I'm going to use the point -4 comma -14. So we have both the slope and a point on the line. Right, so now we're going to substitute. Right, so remember, we never know x or y, but we should know m, x1, y1. So we have y minus -14. That's equal to 3 times x minus -4. Okay, now I'm going to simplify my sign so that double negative makes a positive. I'm going to simplify again. So this is 3 times x plus 4. The double negative makes a positive. All right, so now I'm going to bring down my left-hand side. And on the right-hand side, we're going to distribute. All right, so 3 times x is 3x. 3 times 4 is 12. Now we're going to solve it for y, so we're going to subtract 14 from both sides. So y is equal to 3x minus 2. Right, so y equal to 3x minus 2 is parallel to y is equal to 3x plus 4, and it passes through this point -4 comma -14. Okay, so now let's look at an example that deals with a perpendicular line. And where is my example? So here we want to find an equation perpendicular to 2y is equal to x minus 1, and it passes through -3 comma 4. All right, so we're going to talk about this perpendicular concept in a little bit more detail. All right, and from the notes earlier, it says that the product of the slopes is a -1, or that one slope is a negative reciprocal of the other. So I'm going to kind of isolate this equation over here. We have 2y equal to x minus 1. So let's say 2y is equal to x minus 1. So the first thing I'm going to do is just determine the slope of this line, right? In order to do that, I must put it in slope-intercept form, which means solve it for y, right? Not for 2y. So I am going to divide everything by 2. So if I divide the left-hand side by 2, those 2's are going to cancel. I'm left with y. If I divide x by 2, I have x over 2, or 1/2 x, right? Because x has a coefficient of 1, right? So I have 1/2 x minus 1/2, right? So I divided every term by 2. So x over 2 and 1/2 x are exactly the same. Therefore, I can pull out my slope as 1/2. Right. So now if I'm looking up here, you see this m sub 1 and m sub 2. M sub 1 would just be the slopes of one of your lines. So what this formula is telling us is that if we take our slope, which is let me move some of these wires out of the way. If we take our slope, which is 1/2, and we multiply that by some number, we should get a -1. That some number is going to be the slope that we're going to use for our line. So I want to talk about a negative reciprocal. All right, so what is a negative reciprocal? So I want to find the negative reciprocal of 1/2. So what is the negative reciprocal of 1/2? Well, first of all, if we have 1/2, right, the negative reciprocal would simply mean that I have to take my 1/2 and I'm going to multiply it by a negative, right? So the 1/2 becomes a negative 1/2. And now I'm going to take the reciprocal. So the reciprocal means you just flip flop it over. The numerator becomes the denominator and the denominator becomes the numerator. But your sign is going to stay the same. So if I reciprocate 1/2, I get 2. If I reciprocate negative 1/2, I get negative 2. So the negative reciprocal of 1/2 is negative 2. Okay. So negative 2 is going to be the slope we use. Okay. Negative 2 would satisfy these, will help us satisfy this condition. If we were to take 1/2 and if we were to multiply that by negative 2, we get negative 1. So that's the effect of a negative reciprocal. If you find your negative reciprocal, it will automatically give you a negative 1 when you multiply that negative reciprocal by your slope. So negative 2 is our slope. All right. So just to write that on this example, right? The first thing we're going to do is find the slope. Two y equal to x minus 1. So we multiplied, divided both sides by 2. So y is equal to 1/2 x minus 1/2. We were able to determine that the slope is positive 1/2. The second thing we did was find the negative reciprocal of the slope, right? Because we're dealing with a perpendicular line. This is the only reason why we would take the negative reciprocal, right? So 1/2 times negative 2 gives us negative 1. Right? So negative 2 is the slope that we're going to use, right? And now we're going to find the equation. So we have a slope of negative 2, and it passes through negative 3, 4. Right, so remember that negative 3, 4 is your x1, y1. So I'm just going to rewrite the point slope form. And substitute. So we have y minus 4 is equal to negative 2 times x minus x sub 1, which is a negative 3. All right, I'm going to bring down y minus 4. I'm going to bring down a negative 2. I'm going to rewrite the double negative as a positive. And I'm going to remove the parentheses on the right-hand side. Y minus 4 is equal to negative 2x minus 6. I'm going to add 4 to both sides. And y is equal to negative 2x minus 2. All right, so any questions about perpendicular lines? All right, so at this time, I'm going to stop the recording.